Now let us discuss about the pavers, the machines used for spreading this hot bituminous mix or even sometimes the wet mix macadam. It is used for both. Here in the figure you can see the small paver to big paver. See, the width of the paver varies from anywhere from 2 meter to 16 meters, and these are the common type of pavers used in all our paving operations. And this is the biggest, other common paver used for major projects where you can pave for a width of 10 meters, 8 to 10 meters in a single go. So we have pavers where we can pave. Those paver width or paving width varies from 2 meter to 15-16 meters. If you take any paver has got two component. One is the tractor component, the other one is the screed. So this paver, which has got two machines, tractor and the screed, it is linked by a toe arm. Toe arm. And the basic function of the screed, what you are seeing here in the picture, this is called screed. Actually, this is how the screed looks like. The function of the screed is to lay the material, whether it is wet mix macadam or uh, the hot bituminous mix, lay the material to the required width, required depth and to the required profile. Paver also gives initial compaction. Please remember, paver also does the compaction. So initial compaction of the layer, whether it is bituminous layer or any other layer, is done by the paver. The other function of the screed is to give a smooth surface or smooth mat. There are different types of pavers. You can see here. One is wheel mounted paver. The paver is mounted on wheels. The other one you can see here, the paver is mounted on tracks. This is track mounted paver. This is wheel mounted paver. What are the advantages, limitations of these two types of pavers? Now let us look at the wheel mounted paver. Because it is wheel mounted, pneumatic wheel mounted, it's easy to move and it gives good performance on all types of surface except soft bases. If the bottom surface is weak, we cannot operate this pneumatic wheel driven pavers. So compared to the track mounted paver, the maintenance expense of this paver is higher. Now let us look at the track mounted paver. This paver can be used for bigger lift thickness, that means more or thicker pavements can be, thicker lifts or thickness can be increased. Whenever you want higher lift thickness or higher thickness of the mix, we can use this track mounted paver. It can also be compared to the wheel mounted paver, it can be, its performance is good on soft bases and its performance is good on uphill or down gradients compared to wheel mounted paver. Then when we look at the screed, we have different types of screeds. One is fixed screed, the other one is variable screed. That's how using these screeds only we vary the width of paving. Width of paving. Nowadays, most of the projects, major projects, sensor paver is must, and this is this one type of sensor that is used for getting the smooth mat or required profile. So the horizontal, the profile, crash profile, and the longitudinal profile of the mat, of the layer, is controlled by this sensor. So this is one type of sensor, and you can see other type of sensor, non-contact sensor. Here it is, you can see this is the bottom surface and this is a sensor. This sensor takes the reference of the bottom profile. Accordingly, the mat is laid. And the other type of sensor you can see here is leveling arm, long leveling arm. This, based on this profile which this long beam senses, the mat profile, or otherwise the mat profile, whatever we are paving, depends upon the profile of the bottom layer which this leveling beam senses. So basically here it is a contact lenser, directly the sensor is touching. Here it is non-contact, it senses the reference profile given, accordingly it lays the mat. And third one is a long beam, and these are the components of the paver. This is called hopper, and you can see these are the augers and operators cabin. This is another view where you can see the components of the hopper. These are augers, and this is the screed, and this is the hopper. These are the push rollers. So the material in front of the auger plays an important role on the profile of the mat, whatever the surface we are paving. So let's say, suppose if the material quantity or head of materials in front of the auger is uniform, then we get uniform profile, correct profile. Other case, let's say the head of the material is more here in front of the screed, then the screed rises. The paving is in this direction, this is the screed, and the augers will be there. If the material is more here, the screed rises. That means we do not get uniform profile, the thickness increases. Once the head of material in front of the screed increases, the thickness also increases. The third case, if the material is less in front of the screed, right, again then the screed downs, its screed goes down. So that means the thickness of layer decreases. In that case also we do not get uniform profile. When material is less in front of the screed, the thickness of the layer reduces. When head of material, quantity of material in front of the screed is more, the screed rises while moving and thickness increases. In that case also we do not get uniform profile. When head of material is uniform, or when there is a constant feed for the screed, we get uniform profile. This is very important. So this is another picture where how the profile varies. Here, when this is the correct profile. When auger is overloaded, we get the profile changes because thickness increases. When material is less in front of the screed or auger, the thickness reduces. So basically, unless we maintain uniform feed, uniform head in front of the auger screed, we do not get uniform profile. Some places we may get more, some places we may get less. So while paving, there will be, as far as possible, less number of people should be involved. Otherwise, it's something like too many cooks spoil the food. So the other one is what this paving is a continuous operation. Always, paving is a continuous operation. Ideally speaking, except for an important break, paver should not be stopped. Paving is an art. Otherwise, we do not get the required profile. It's a continuous operation. Any paving operation always it's a continuous operation. Wherever we stop the paver, that is, we generate more and more weak planes. The moment we stop, that means we should know that we are producing a weak plane. So as far as possible, stopping of the paver to be minimized.